Alright, let's be real for a second. You know that feeling. The lights flicker. Your Wi-Fi dies. Or maybe, you just opened your latest electricity bill and nearly choked on your artisanal toast. The grid? It's great, until it isn't. And for most of us, power means big bucks, massive infrastructure, and a whole lot of stress. But what if I told you there's another way? A way so simple, so ancient, so unbelievably cheap, it might just make your high-tech smart home look, well, kinda dumb. Picture this: rolling green hills, horse-drawn buggies, no power lines cutting across the sky. We're talking about the Amish country of Lancaster, Pennsylvania. A community that lives by a different set of rules, often rejecting the conveniences of modern technology and, crucially, the public power grid. But even without the grid, life still demands a certain level of power, right? For lights, for tools, for charging the occasional essential item. So, how do they do it? And more importantly, can we learn anything from their off-grid genius? This is Daniel, a young man from the Miller family. He's not your typical tech bro, obviously. You won't find him scrolling TikTok. But he possesses something far more valuable: a deep understanding of his environment and an insatiable curiosity. Daniel faced a challenge most of us take for granted. His younger sister, Sarah, loved to read, but kerosene lamps strained her eyes, and small, store-bought batteries for her battery-powered lantern were a constant, expensive drain. There had to be a better way to bring light into their evenings. On the Miller farm, like many Amish homesteads, their well wasn't just a hole in the ground, it was a lifeline. Fed by a natural underground spring, it provided crystal clear, cold water year-round. But here's the kicker: it had a constant, small overflow. A steady, gentle trickle that usually just disappeared into the surrounding soil. Most folks saw it as a happy byproduct of a healthy spring. Daniel, however, saw something else. He saw untapped potential. He saw movement. One lazy afternoon, watching that continuous flow, Daniel's mind started whirring. He remembered stories of old-world grist mills, powered by massive water wheels. He'd seen toy water wheels kids made in the creek. What if that tiny, constant stream from their well's overflow could turn something? Something small? Could that something small generate even a whisper of electricity? It seemed far-fetched, even a little silly, but the seed of an idea had been planted. And once planted in a curious mind, it's hard to uproot. Daniel knew his idea would raise eyebrows. The Amish community values tradition and practicality, and experimenting with electricity wasn't exactly a common pastime. So, he enlisted his cousin, Samuel, a slightly older, equally resourceful young man, and they set up a clandestine workshop. Not in a fancy lab, obviously. No, their lab was an old, dusty corner of an unused toolshed, tucked away behind the barn. This was where the magic, or at least the tinkering, would begin. They had a vision, but almost no budget. Budget? What budget? Their initial investment capital was exactly $0. So, Daniel and Samuel became master scavengers. An old bicycle wheel, bent but reparable, was the first prize. Next, a defunct washing machine motor, destined for the scrap heap, caught Daniel's eye. A motor can be a generator, right? He mused. Then, discarded plastic buckets, perfect for crafting turbine blades. Every piece of junk was a potential component in their grand experiment. This wasn't just recycling, this was ingenious resourcefulness. After weeks of scrounging, they had the bulk of their components. But a few crucial items had to be purchased. A spool of copper wire, some waterproof epoxy, a few tiny LED lights, and the absolute game-changer, a cheap, simple voltage regulator. This little circuit board would make sure the power was stable and wouldn't fry their delicate LEDs. Total cost for these essentials? A whopping $45. Yep, $45. That's less than your average takeout order, and they were about to build a power plant. With their newfound treasures, work accelerated in the shed. The bicycle wheel was stripped, the spokes reinforced, and the plastic bucket bottoms were cut and shaped into crude but effective turbine blades. They carefully attached these blades to the wheel's rim, creating a sort of water paddle wheel. It was rough, it was ready, and it looked like something out of a kindergarten science project. But Daniel believed in its potential. This was going to be the heart of their power station. Next, the washing machine motor. Most people would just see junk. Daniel and Samuel saw a potential generator. They carefully disassembled it, understanding how magnets and coils interact. They then modified it, bypassing certain circuits to allow it to generate a small current when spun by their water wheel. This step was crucial and required a surprising amount of electrical intuition. Turning a motor into a generator, that's not something they teach in basic carpentry. The challenge wasn't just spinning the wheel, it was directing the well's overflow water efficiently. So, they constructed a small wooden flume, a channel designed to funnel the steady trickle of water onto their newly fashioned turbine blades. It was a simple, gravity-fed system. They carefully positioned it near the well, testing the angle and flow. Would the force be enough? The anticipation was palpable. They watched, holding their breath, as the first drops hit. And, nothing. The water hit the blades, but the wheel barely budged. It spun for a second, then stopped. Total, absolute, deflating silence. Daniel's heart sank. All that work, all that scavenging, all for a pathetic, limp spin. Samuel patted him on the back. Back to the drawing board, he murmured. It was a classic DIY moment, the grand vision crashing into the harsh reality of physics. But true innovators don't give up at the first hurdle. They iterate. Undeterred, Daniel and Samuel returned to the shed. They analyzed the problem. Not enough torque. The blades were too flat, catching the water inefficiently. So, they redesigned. They meticulously reshaped each plastic bucket blade, giving them a more aggressive curve, like miniature scoops designed to harness every last ounce of kinetic energy from the water. They also adjusted the angle of the flume, creating a faster, more direct stream. This wasn't just trial and error, it was applied engineering. 3 weeks later, they were ready for the rematch. The sun was setting, casting long shadows across the farm. They guided the water down the re-angled flume. This time, as the stream hit the newly curved blades, the wheel began to turn. Slowly at first, then faster and faster. A soft whirring sound filled the air. Success! The washing machine motor, now a generator, was alive. It was spinning, generating that precious, elusive current. A quiet cheer, a shared glance of pure triumph. Now for the ultimate test, actual electricity. Daniel connected the leads from the generator to their humble voltage regulator, and then to a single, tiny LED. He flicked a switch, and in the dim light of the evening, a small, but undeniable, glow appeared. A tiny blue light. It was barely visible, but to Daniel and Samuel, it might as well have been a stadium floodlight. It was tangible proof. From scrap metal and well water, they had conjured light. They had harnessed nature. And it cost them virtually nothing. A single LED was nice, but Daniel envisioned more. He knew they needed to store this precious energy. So, over the next few weeks, they collected old, discarded 12-volt car batteries, refurbished them as best they could, and wired them into a small battery bank. The micro-hydro system would constantly trickle charge these batteries, day and night, building up a reservoir of power. This meant they weren't just making light, they were storing it, ready for whenever it was needed. The moment of truth arrived for Sarah. Daniel led her to her bedside, where he had installed a small, unobtrusive LED lamp, powered by their well water system. He flipped a simple switch. A warm, steady glow filled her small corner of the room. Sarah's eyes widened. No flickering, no smell of kerosene. Just clean, quiet light. She could read her books for hours now, without straining her eyes or worrying about dwindling batteries. It was a small miracle, delivered by her brother's ingenuity. But the power wasn't just for reading. With the 12-volt battery bank, Daniel discovered other possibilities. Small, efficient LED strips could illuminate the barn for early morning chores. Jacob, their uncle, could now charge his portable, battery-powered radio for weather reports without needing new D-cells every week. It wasn't about powering a refrigerator or a TV, but about meeting essential needs with a sustainable, self-sufficient energy source. This was pragmatic power, Amish style. Naturally, news of the well power system couldn't stay a secret for long, even in a quiet community. At first, there were whispers. Skepticism. Some elders questioned the need for electric light. But when they saw Sarah reading comfortably, or observed the efficiency of the barn lighting, curiosity began to outweigh tradition. Neighbors would accidentally wander past the Miller farm, observing the small turbine silently spinning near the well. Daniel found himself answering more and more questions. The implications were huge, especially for a community that values independence. Imagine reliable, clean power for under $50. No grid connection fees, no monthly bills, no fossil fuels. Just the continuous, gentle flow of water. This wasn't just a hack, it was a paradigm shift. It showed that with ingenuity, resourcefulness, and a willingness to challenge assumptions, you could achieve incredible things with minimal investment. The Amish microhydro system was becoming a quiet revolution. Let's break down the genius. The system leverages kinetic energy. Water, flowing from the spring-fed well's overflow, hits the curved blades of the turbine. This rotational energy spins the repurposed washing machine motor, which now acts as a direct current (DC) generator. The generated electricity then flows through a voltage regulator, stabilizing it, before being stored in the 12-volt battery bank. It's an elegant dance of physics and salvaged parts. No rocket science, just smart engineering. So how did Daniel keep the cost to just $45? It boils down to a few key factors. First, nearly everything was repurposed or scavenged. The bike wheel, the motor, the buckets, all free. Second, the lack of labor costs. Daniel and Samuel built it themselves. Third, the simplicity of the components. No high-tech inverters or complex control systems. Just basic, robust electrical components. The cost was minimal because the ingenuity was maximal. Think about that next time you buy a fancy gadget. Beyond the cost savings, consider the environmental footprint. This system is a masterclass in sustainability. It uses a perpetually flowing natural resource, water, without depleting it. There are no carbon emissions, no hazardous waste, and minimal manufacturing impact because of all the repurposed materials. It's literally green energy in its purest, most localized form. Compare that to the giant fossil fuel plants pumping out pollutants. This tiny Amish system is punching way above its weight. Now, let's be realistic. This isn't going to power your entire house with its AC, electric stove, and gaming PC. It's a microhydro system, generating a modest amount of power, perfect for low-draw applications. You need a consistent water flow, ideally from a spring-fed well or small stream, and it's DC power, so if you want AC, you'd need an inverter, adding to the cost. But for what it's designed to do, light, small charging, it's incredibly effective. What started as Daniel's secret project quickly became an open secret. Other Amish families, inspired by the Millers' success and the dramatic improvement in their daily lives, began to adapt Daniel's design. Soon, small wooden flumes and repurposed turbines could be seen near well houses across the county. Each system was slightly different, tailored to their specific water flow and needs, but the core principle remained: simple, cheap, sustainable power from the earth. Daniel became a quiet consultant, sharing his knowledge freely. This isn't just an Amish story. It's a human story of ingenuity. The principles Daniel applied, repurposing, resourcefulness, leveraging natural forces, are universal. Imagine this system in developing countries, bringing light and communication to remote villages. Or for preppers and homesteaders seeking true off-grid independence. The $45 Amish microhydro system isn't just about wells, it's a testament to what we can achieve when we think outside the box, or in this case, outside the grid. Daniel's story reminds us that advanced technology doesn't always mean microchips and supercomputers. Sometimes, it's about a deep understanding of basic physics, a keen eye for overlooked resources, and the courage to tinker. It's about finding elegant solutions to practical problems, respecting natural cycles, and building a more resilient way of life. This $45 power plant is more than just a device, it's a philosophy. A philosophy of self-reliance, sustainability, and humble innovation. So, are you thinking what I'm thinking? Could you build one of these? If you have a property with a consistent water flow, a spring, a stream, or perhaps even a continuous overflow from a well like Daniel's, the answer is absolutely yes. The schematics are simple, the parts are cheap, and the satisfaction of generating your own power is priceless. It might not power your whole house, but for charging phones, running LED lights, or even a small fan, it's a game changer. What Daniel and Samuel built for $45 isn't just a microhydro system, it's a legacy of ingenious problem solving. It's a reminder that necessity is the mother of invention, and that sometimes, the oldest ideas, applied with a fresh perspective, can yield the most revolutionary results. The next time you see a trickling stream or an old washing machine motor, don't just see water or junk. See potential. See power. See a future where we're all a little more connected to the earth, and a lot less dependent on a fragile grid. So there you have it. The incredible story of the $45 Amish microhydro system. It's not about being anti-technology, it's about being smart, resilient, and connected to the rhythms of nature. It's about realizing that real power doesn't always come with a huge price tag or complicated engineering. Sometimes, it just takes a curious mind, some scrap parts, and a steady stream of well water. What's your next off-grid project? Let me know in the comments below.